Hola muchachos y muchachas. Today we're learning about 10.4, inscribed angles. Woohoo! So first we got to know what an inscribed angle is. An inscribed angle looks like this angle right here. It has the vertex on the circle, so the vertex is R. It's touching the circle, it's on the circle. And then the two endpoints of the angle are also on the circle. So S and Q are also on the circle. That is an inscribed angle. It's an angle which is in the circle. Here are some more examples of an inscribed angle. You ready to hear me sound like Oprah? This is an inscribed angle. This is an inscribed angle. This is an inscribed angle. They're all inscribed angles. So yeah, all the pictures look a little bit different. On this first picture here, the inscribed angle is actually also, one of the sides of it is the diameter. And the other two pictures look a little different because this picture in the middle, it's kind of like straddling the center point. This one over here is squished to the side, but they're all examples of inscribed angles because in order to be an inscribed angle, it has to have the vertex on the circle, check, check, and check. And it has to have the two other points of the angle on the circle as well, and all of these do. So these are all different examples of an inscribed angle. All right, now that we know what an inscribed angle is, let's move on to one more vocabulary word. An intercepted arc. An intercepted arc has endpoints on the side of an inscribed angle, like Q and S right here. Those are going to be the endpoints of the intercepted arc. So in circle C, minor arc QS is intercepted by the inscribed angle. So basically an intercepted arc is just an arc for an inscribed angle. We have two theorems today that have to do with inscribed angles and intercepted arcs. Take a look at this first theorem. Theorem 10.6, the inscribed angle theorem. This theorem here says that the measure of angle 1 is going to be half of the measure of arc AB. So for example, if the measure of arc AB was 80 degrees, then the measure of angle 1 would be 40 degrees. It's always going to be half of the intercepted arc. This picture is going to make the theorem make a little bit more sense. If you take a look at this picture here, the line CE, that's going to be the diameter of the circle. And then notice this is a right angle here. We all know that right angles are 90 degrees. And we also know from previous lessons that the measure of this right here is going to be 180 degrees because we know the entire circle is going to be 360. So we know that CE is going to be 180. So it makes sense that this right here is an inscribed angle, angle CDE, and the measure of that inscribed angle is 90 degrees, which is half of the arc CE, which is the intercepted arc for the angle. So you can kind of see where it makes sense a little bit. We're going to do a few practice problems using this theorem. Here's the first one. In this circle, we want to find the measure of angle P. So angle P is right here. I know it's going to be half of the intercepted arc. The arc is MN, which is 70 degrees. Half of 70 degrees is 35. All right, the next problem, they want us to find the measure of arc PO. PO is right here. 56 is the inscribed angle, so PO is going to be twice as big, so 56 times 2, that's going to be 112 degrees. So the measure of arc PO is 56 times 2, or 112. Here's a problem for you guys to try. Go ahead and pause the video, give this problem a try, and then you can check your answer. All right, this problem looks a little trippy, but once I kind of draw on it, it's going to make more sense. So the first one is the measure of arc CF. Now CF is going to be this arc right here. And at first it's tricky to figure out where the inscribed angle is, but watch this. Okay, so that's the inscribed angle for the arc CF. It just has to have this endpoint on the circle and then these endpoints on the circle as well. So the inscribed angle is 40 degrees, which means that the measure of the arc has to be 2 times as big, so it's going to be 80 degrees. And the next one is kind of tricky as well, but we're going to look for the measure of angle C, which is this angle right here. Notice this could be an inscribed angle. This could be an intercepted arc. So if the arc is 98, we have to cut that in half. Half of 98 is 49. So the measure of angle C is 49 degrees. All right, we've got one theorem down and one to go. Here's the next theorem for today. Theorem 10.7 says, you can tell if two inscribed angles in a circle are congruent if the intercepted arc is congruent. So in this picture here, we can tell that angle B is congruent to angle C if this is the same intercepted arc. If they both share the same intercepted arc, then the inscribed angles for both of them are congruent. We're going to use this theorem in a couple problems. Here's the first one. In this problem, they want us to find the measure of angle T. I notice that this is angle T right here, and this is angle U right here. Notice both of those angles share the same arc. So because they share the same arc, we can say that they're congruent. So we can say that 3x minus 5 is equal to 2x plus 15. Then we can solve it for x by subtracting 2x on both sides, adding 5 to both sides. We get that x is equal to 20, and since they want us to solve and find the measure of angle T, we're going to substitute the 20 into the measure of angle T, and we're going to get 55 degrees. So the measure of angle T is 55. Here's a problem for you guys to try. Go ahead, pause the video, give this problem a try, and then you can watch the video for the answer. Alright, in this problem, they're telling us that the measure of angle S is 3x, measure of angle V is x plus 16. Notice those angles have the same intercepted arc, therefore they are equivalent. 3x is equal to x plus 16, so 2x is equal to 16, so x is equal to 8, and then to solve for the measure of angle S, we're going to say that it's 3 times 8, which is 24. So the measure of angle S is 24 degrees. All right, now that you guys have learned those new theorems, we are going to do what has been your favorite thing in geometry this year. We are going to do a proof. Hooray! Here's the first proof for us to take a look at. In this proof, they want us to prove that triangles are congruent. Triangle JMN, this triangle right here, is congruent to KLN. How can we prove that two triangles are congruent? Do you guys remember the theorems that we had to prove triangles are congruent? We could either use side, 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 side angle, side. Those are the theorems that we're going to use to prove that triangles are congruent. Now let's see what information we're given so far. So JM is congruent to KL. What does that mean for us? If those arcs are congruent, then that means the inscribed angles are congruent. So to start this proof off, I could say that angle JNM is congruent to angle KNL because of one of the theorems that we just learned today. It is 10.7, so that's because of theorem 10.7. All right, so we know that this angle here is congruent to this angle here. Let's see, if N is the middle point of the circle, what does that make JN? That makes JN a radius. And then NL is also a radius. So we could say that JN is congruent to NL because all radii in a circle are congruent. So I'm going to write the word radius here, and by that I mean that because they're both radius, therefore they are congruent. Also, KN is a radius and NM is a radius, so by the same reason I can just include this here. Because they are also radius, so therefore they are congruent as well. So far we know that these sides are congruent, and we know that the angles are congruent, so therefore we can use side angle side to say that triangle JMN is congruent to triangle KLN. All right, do you guys think you can do one of these on your own? Let's give it a try. This is the last problem for today. Go ahead and pause the video, see if you can figure out how to do a proof for this problem. Alright, so I noticed that I'm still trying to prove that two triangles are congruent to each other, so I'm back to using like the side angle side reasons in my proof. So I have to figure out how to show that some of the sides or some of the angles are congruent. Let's take a look at what we've got here. We know that QR, the arc QR, is congruent to arc ST. What can we do with that information? Well, if arc QR is congruent to arc ST, then that means that chord QR is also congruent to chord ST. So we can say that these are congruent, and that is because of something we learned in a previous video, which said if the arcs are congruent, then the chords are congruent. So I'm going to say arcs are congruent, then the chords are congruent as well. And then they also tell us that PQ is congruent to PT, so by the same reason, we could say, well, that means that chord PQ is also going to be congruent to chord PT, because of the same reason. If the arcs are congruent, then the chords are congruent. That's why we can say that. Alright, so far I have two sides. I either need a third side or I need an angle. And it would have to be angle T and angle Q. So for my last thing, I either have to prove that Q is congruent to T for the angles, or I have to prove that PR is congruent to PS. We are going to be able to show that chord PR is congruent to chord PS. What would we need to know in order to prove that those chords are congruent? We could use the same thing that we just used, right? If the arcs are congruent, then the chords are congruent. Well, what's the arc for PR? That would be this arc right here. And the arc for PS, that would be this arc right here. Is there a way for us to show that those arcs are congruent? There is. Let's start by saying that PQ is congruent to PT, and we're going to say arc PQ is congruent to arc PT. That is some given information. Then we're going to add the same thing to both sides. We're going to add arc QR. Let's do that one. We're going to add QR to both sides. And we can do that just because of the addition property of equality. Then we're going to substitute in this second one here. We are going to substitute ST for QR, and we can do that because of substitution, because it was given that they're equivalent. So we're substituting in that step. All right, and for the grand finale, we're going to combine these different arcs together. So PQ plus QR, that's going to be PR, and we can just say arc addition. We're adding those arcs. And then, so I'm going to say arc addition. And then PT plus PS, that's going to be PS. So those arcs are congruent. Okay, now because arc PR is congruent to arc PS, we know that chord PR is congruent to chord PS. So we can say chord PR is congruent to chord PS because arcs and chords are congruent. And now we know that all three sides of the triangles are congruent, so we can use side, side, side to say therefore triangle PQR is congruent to triangle PTS. Perfect, there we go. All right guys, that was the last thing in this video. Great job today. Go ahead and take a picture of your notes, submit it on Canvas, and then you are good to go.